So from the first time I opened Bewley's book on traveling waves on transmission systems when I was like, in the Navy, to the point where I had actually conquered all the equations and came up with an engineerable antenna structure out of it. Well, that's from let's say 1972 to 1992. That's how long it took to figure it out.
20 years.
At least, yeah.
This is from a man who was recreating Tesla's work at the age of 15 in his garage laboratory.
Yeah, well, this project's a lot more complicated than that, but it's the same. There's no mathematical analysis available for any of this stuff. There's no way to express it analytically. But I came up with a way to do it out of Steinmetz's method.
What do you call your method?
It's called the Verser method.
What was Steinmetz's called?
And everything has to be expressed in 4 terms rather than 2.
Ah.
That's the problem, because you can't solve an algebraic expression higher than the 2nd degree, and mine were all 4th and 8th.
Your algebraic expressions are 4th and 8th degree.
The problem, the Alexanderson problem or the Tesla transformer problem in the most general expression is an 8th order differential equation. So there's no algebraic solution. It's never been developed. Kind of for the 3rd, not really for the 4th, and anything beyond that, forget it. That's where this polyphase mathematics I'm studying is the only way out. And that's a Verser system too.
You're incorporating this new polyphase mathematics.
No, it's not new. It was developed for electrical engineers by a Westinghouse mathematician in like 1918.
Almost 100 years old.
Yeah, and then that allowed, it made it possible to have reasonable calculations without horrible masses of like 9-dimensional matrix equations and stuff. You can't do any real engineering work with that stuff. It's too complicated.
So your Verser method...
Not my Verser, their Verser mathematics.
Yours would allow a normal engineer to engineer this.
Well, here's the problem. Okay, the problem is all Verser systems are only made for the dimension of time. There's no algebra for space.
I was just going to let him know that a concerned citizen called in and said that the truck is now gone from the residence.
You can't analyze any of this stuff, because it's not a problem in time, it's a problem in space.
So your Verser method
I came up
the
with the Verser method for space. So you don't have to fool around with all that quaternion and the rest of that stuff that doesn't work. None of that stuff would work. But that's what all the books are based on. Heaviside said throw the whole thing in the garbage. And that's exactly what I did.
So the reason we don't have floating skateboards like in Back to the Future is because we're using this outdated 2D math instead of your 4th and 8th dimensional.
No, it's more complicated than that. First of all, you have the order of magnitude, or the degree of the equation is what it's called. But there's no algebra for space at all, in any degree.
Any degree.
Any degree. Algebra is the mathematics of time, not space. That is the whole flaw in the mathematical analysis of all these space complex structures.
So this is not really algebra then.
It is algebra, but it's a new type of algebra.
It almost sounds like it's a totally different animal, but it's okay.
You have to be able to make the dimensional transformation.
Would this new method
That's all.
deserve its own name? Perhaps dollar...
Space algebra.
Dollar algebra?
The paper written by Dr. Alexander McFarland that allowed all this, he was the one that figured it out.
From Austin.
The guy at the University of Texas.
Texas.
Yeah. And he's the one that figured it out, but he didn't make it engineering. I had to take it from there and turn it into something that seemed engineering. And then I got it to the point where it defined all the movements of transmission in any transmission system, like transformer windings or Alexanderson antennas or filter networks. It opened a whole different way of looking at all that. You didn't have to use all this brutal partial differential equations, and you're still left with the same order You can't solve those things. There's no simple formula to solve it.
So its primary benefit is it would allow an ordinary engineer to calculate spatial math.
Well, it would
Spatial.
allow a developmental engineer that was smart enough to take raw mathematics, okay, and then apply it to an actual volts and amp situation. There's not a lot of people like that around.
So this math was much more grounded in that a normal person could figure it out. It could be applied
Well,
to engineering.
this math is operating on a theoretical level.
This math?
What I'm talking about, it operates on a theoretical level. It's still not possible to get an exact calculation on a coiled winding because you have no way of measuring the quantities involved.
Of copper?
No, the space quantities, capacitance and inductance. There's no way to calculate or measure that
There isn't.
because you can't get into it because you're dealing with traveling waves that moves. So you have to come up with a 4-quadrant inductance and capacitance equation. That's how you work the math in. So that requires a lot of experimentation and fooling around, and I can't do that living in my car. But if I use lumped networks, like Alexanderson networks, then it's a snap, because all the quantities are directly calculable. In fact, they're usually fixed valued units, like regular coils and condensers. Because the Alexanderson system is an analog system. Tesla's is not analog. It's direct. The Alexanderson system is an analog computer that models the Tesla system. And it turns out to be, it doesn't matter if you have a real version or you have an analog version, they both work. That's the miracle. They both do the same thing. Where one is a distributed winding with complex quantities, the other thing is a mathematical model of it made out of coils and capacitors. That was Alexanderson's great discovery. The power comes from another space, not inside the sun. It's from somewhere else.
It's channeling from another dimension.
Well, that's the way the physicists like you to talk.
How do you like it?
You don't use dimensions. So it's either other coordinate system or another space or another time, or but I don't like to call it different dimensions.
Okay.
That confuses the mind.
Yeah.
It's only one dimension of space. You can't say 3D space or 4D space. That doesn't make any sense. There's only one dimension of space. Space. And when you think about it like that, then you can have space and you can have counter space, because they're both in the dimensions of space. 3D space and 2D space, and those things are just those are coordinate systems. They're mathematical abstractions. You can have any number that you want. It's arbitrary. But they force the whole mind state to think like that. That way you only think in terms of graph paper. You don't think in terms of generalized coordinate systems. And then when you get into this 3-phase math, like I've been working on in that book, you see then all of a sudden you have a whole different type of coordinate system. 9 dimensions, according to the physics world. You have 9 dimensions in time, which is only 1 dimension in time, because they're all frequencies of 60 cycles a second. But some turns forward and some turns backwards and some don't turn at all. So you have 9 components altogether. So algebraically, normally you can't too complicated. You have 9 simultaneous equations. It's too complicated. You can't apply it to practical problems. Unless you like to spend all day dealing with matrix algebra, which nobody likes. So this guy that came up with that book, in that paper, he figured out a way to do it all geometrically. So he didn't need 9 dimensions. Reduced it to 2. Yeah.
Sacred geometry is a comeback in that.
Well, no, but there's a 5-phase system all applies to sacred geometry, but there is no existing 5-phase system. Your book does not develop that mathematics, but it gets you started on it. It gives you just enough that you can carry it to other coordinate systems. It takes a lot of figuring.
Have you gotten further?
Yeah, I've started that. I'm almost about ready to write a paper on the book.
the main innovation, the main component of this etheric caloric ground radio is the ground antenna.
Yeah, the earth contact.
Okay.
Yeah.
And it has to be a massive installation, at least 150 feet into the ground with a tree root-like
Yeah,
pattern.
right.
Okay, so, and then the transformer on top.
So not the transformer, but the reflector.
The reflector. So this reflects off the ionosphere.
Yeah, then the other end is you have to have this hideous voltage.
And your Versor algebra can control this voltage?
No, the Versor algebra is just to describe the phasing process, that's all.
So this is where the phasing process is where the magic comes
No,
in?
how it becomes monopolar, that's what the Versors describe.
How?
Yeah, otherwise it's a very simple transmission engineering equation. The only problem is there's no math to figure out the waves on the coil. It's never been invented because it's too high of an order of the equation. That's where the Versors come in.
So to get it
designing the actual is figuring out how the energy moves in the transformer and becomes monopolar. Describe that mathematically, and then figuring out from the number of turns, the diameter, and the spacing is what's the frequency and the harmonic ratio is going to be. That's one of the most complicated mathematical problems in existence. So far, it's never been done. I'm the only one that's even become close to it.
So the geometry of the counter space is what the Versor algebra helps you determine?
Yeah,
And that's what controls the conversion to a monopolar energy.
right.
Okay, I can't believe I actually got
It's like a wave interaction, cancellation. You get the waves, they all cancel out, and you're left with the monopolar component.
the geometry is the most important part. The
Yeah.
spacing.
So that determines the number of turns and the spacing and the diameter and the length, and then the ratio of the size of the ball to the size of the Earth.
So this geometry is all critical. The size of this, the turns in that, and this,
Yeah.
it all has to.
Right.
And this is what people can't do.
And as of yet, it is not engineerable because mathematics is not developed far enough for higher order equations, so it's just ignored. But they, when they were designing the substation transformers, they couldn't ignore it because it would cause them all to blow up. Everything kept blowing up. The streets of New York would just lift up in massive explosions as the cables underneath exploded out of control. It would cause a lot of complications and piss people off, and and lawsuits and the whole deal. They couldn't control. This stuff would just run on its own.
It's a DC system?
AC.
Oh, AC.
Yeah, the first
Tesla
AC
fixed it.
systems. Yeah,
Tesla
it
fixed it, so
started
it's
with
polyphase.
the elevated railway and whatever in New York City. They had to build the biggest power plant the world had ever seen to run it. It was a steam plant of 50 megawatts, and they didn't know how to control these oscillations, and they had no way to measure them back then. There was no oscilloscopes, or the meters wouldn't respond to this stuff. And the whole system was designed for 60 cycles, but a 200 and something cycle parasitic oscillation got started on it, and the voltage went from 11,000 to 250,000 volts and blew all the cables up, and then the whole system faulted into it with 1 billion watts of fault current, just blew up the streets. Manhole covers were shooting into the air, and the whole thing took the big choke. It did the burn down first week of operation. Everybody was pointing the finger at everybody else as to why it happened.
This was New York.
And Steinmetz wrote his book about that. That's where he applied his transient wave theory to describe how all this came about, and it's a whole chapter in his book was the elevated
discharges.
railway explosion.
This is book electrical discharge.
He calls it theory and calculation of transient electric phenomena. He came up with the mathematics to describe how all this came about, and made him world famous again. Just like his hysteresis equations and his Steinmetz method, and he just kept making himself world famous by writing these incredible books that everybody could understand and you could actually calculate, and they were all experimentally proven.
Wow.
He used real power lines and did real experiments or described real mishaps of things blowing up, and he was the guy that, all of a sudden they pull him on carpet, and the Steinmetz is going to have to tell them why the whole city blew up. Because everybody's in trouble. We need some answers. We can't turn the thing back on. We can't control it.
Wow. That's amazing.
So he figured out where these things originated from and how to suppress them so they wouldn't come about.
I see. Now,
They could tame it, and that required understanding these Tesla waves inside the substation transformers. So he couldn't do that. So there's a guy later that wrote a book. That was my first. I started studying it in high school. That wrote this transmission book which is not normally for high school students to read. It was like the most intense electrical theory book ever written.
By who?
A guy named Bewley. He was Steinmetz's successor.
Oh, he was one of them.
Yeah, and he was the one that came up with the four-dimensional, or fourth-order differential equations for transformer waves, but they still had no solutions. And his model was not really accurate, but it was a good start. So at any rate, I had learned that in high school and in the Navy, so I had full exposure to that, so I could think in that manner. So I didn't see coils and transformer windings the same way they were normally understood. I saw them in their archetypal form, because through that book I could visualize all these waves and start to engineer them. But it took 40 years to harness it, which led to that antenna and landers. That took 40 years before I had an actual solid algebraic equation and a physical model.
So your antenna at Landers was a work of art in its geometry.
That was, the result of, and it's secret.